So for me, it's very, very exciting to have Carl with us today to help us kind of puzzle out this whole question of where the world seems to be going. Carl?
Thank you. I will be talking not so much about whether there's intelligent life elsewhere, but whether there's intelligent life here. I want to talk mainly about the development of science and technology and its consequences. I will make some economic statements, which, if I'm extremely lucky, will be as competent as Lester's astrophysical statements. We are a tool-using species. It's our only hedge against disaster. Our ancestors, when they came down from the trees 10 million years ago or something like that, were not faster than the competition, not stronger than the competition, not better camouflaged, not better diggers or swimmers or flyers or runners. All we had going for us was being smarter, having hands with which we could build things. And that was and has been the secret of our success. We were technological from the beginning. So 2 million years ago, our ancestors had a vast stone and wood technology. We knew how to chip and flake and carve, and that's how we managed to make a living, and a very good living it was. That hunter-gatherer way of life spread to all 6 continents, existed for 1 million years, and the bulk of the evidence is that most of those economies had surpluses, and that the amount of time that people work in hunter-gatherer societies, even the paltry remnants that are around today, is less than the fraction of time that people work in modern industrial economies. So immediately there is a real question about how much progress has been made in the last 1 million years. The critical step in human history before the present time is the domestication of plants and animals, the agricultural revolution of roughly 10,000 years ago, where it was figured out that you could, instead of simply harvesting the vegetables and nuts and fruits that grew all by themselves, you could use, generally in river valleys, the natural irrigation and plant crops, and therefore produce a much larger food surplus than, in a small area than was otherwise available. That meant that the previous way of life came to an abrupt halt. The previous way of life, the hunter-gatherers, was a nomadic style of existence. And if you're a nomad, you follow the game, you wander, you carry your possessions on your back along with your children, and that means you have extremely few possessions. Modern hunter-gatherer societies have no sense, virtually none, of personal property, no sense of ownership. The game is shot and it is distributed to lots of people, and it's done as a matter of course among the I can't say that exactly because you got to do that and the cut simultaneously. Of the Republic of Botswana, the prey belongs not to the person who shot it, but the person who made the arrow. It's a very different kind of lifestyle, which it's very interesting, but I won't spend much time on it. But what I'd like to stress is that human beings have spent something like 99% of their history in an extremely different kind of social situation extremely different kind of economic situation, but a very familiar kind of technological situation to what we have today. And to the extent that we have emotional predispositions that are hereditary, a lot of them must be geared to those hunter-gatherer times and find very little expression in modern industrial economies. Now, after the settled agricultural revolution, it was clear that you had to organize large numbers of people over large areas along the Nile or the Yangtze. This required a political organization that had never been seen before. It involved hierarchical political structures which don't exist in any hunter-gatherer society on the planet. It involved enforcement, police, armies, which are extremely rare among hunter-gatherers. It involved slavery, which is unknown among hunter-gatherers. We are living in the last 10,000 years in an extremely anomalous circumstance for the history of the human species. Now, the technology has been monotonically developing, always for short-term advantage. It's extremely rare that a technological development is forsworn because 100 years from now we can see that there will be some serious negative consequences, even though 10 years from now we can see that there will be some significant advantage. We never think on those time scales. 100 years from now we'll be dead. But someone else's watch. Let them look out for that. Well, this passion for the short term over the long term, coupled with extraordinary technological prowess, has, I maintain, produced an extremely dangerous and critical circumstance at the present time. The technology now permits us to affect the entire planet. And so, apart from the evident economic interdependence of the planet, which Lester so brilliantly discussed just a moment ago, there is an enormous technological interdependence, and I'd like to give a few examples. The innocent act of burning fossil fuels, coal, peat, wood, natural gas, petroleum products, has consequences. It seems the most natural thing in the world. The global economy is geared mainly on fossil fuels. But every time you burn a lump of coal, let's say, you combine the carbon in it with the oxygen in the air, that's where the energy comes from, and you produce carbon dioxide, CO2. Now let's just spend a moment on carbon dioxide. The air in this room has 0.03% carbon dioxide in it. It's a minor constituent. It's odorless, it's colorless, it's not poisonous. And it's transparent, right? Here we are seeing each other. It must be transparent. It's transparent in the visible part of the spectrum, the ordinary kind of light that our eyes are sensitive to. But in the infrared part of the spectrum, the light beyond the red, it is not fully transparent. And at a wavelength like 15 microns, it's opaque. If our eyes were good at 15 microns, we could not see our finger in front of our face, which is why our eyes are not good at 15 microns, because that would be perfectly useless. Now, what determines the temperature of the Earth? Visible light comes from the sun, hits the surface of the Earth, some of it's reflected back to space, the rest of it is absorbed by the ground, that goes into heating the Earth. And what we have is a kind of equilibrium. The Earth radiates to space just the same amount as what it absorbs from space, and that equilibrium determines the temperature of the Earth. But that is only part of the story. The other part has to do with the greenhouse effect, so-called, because of an imagined analogy to a florist's greenhouse. But the basic idea is that transparent atmosphere lets the sunlight in, but when the surface tries to radiate away into space in the infrared, that radiation is impeded by the partially opaque atmosphere in the infrared. Carbon dioxide is one of the causes, water vapor is another, ozone, chlorofluorocarbons. There's a number of molecules that are greenhouse gases and hold the heat in. Now, the lifetime of carbon dioxide molecules in the atmosphere is measured in thousands of years. So every carbon dioxide molecule we put in the atmosphere will stay there for the foreseeable future and increases the greenhouse effect and therefore increases the temperature of the Earth globally, the worldwide temperature. The curve of carbon dioxide as a function of time is a kind of increasing sawtooth like that. The up-down is a seasonal cycle of vegetation on the planet. And the amount of carbon dioxide is monotonically increasing and has been doing that for many decades, in fact, possibly since the beginning of the Industrial Revolution. It is now entirely clear that the Earth's temperature is increasing as well, globally. At estimated rates of industrial and domestic use of fossil fuels, you can make some predictions. And there's, of course, some uncertainty, but a typical prediction is that at the projected rates of fossil fuel use, by the middle to late 21st century, that is roughly a century from now, the global temperature will have increased sufficiently to make massive climatic change on the planet. A typical prognostication is the conversion of the Ukraine and the American Midwest into something little different from scrub deserts. That will have significant economic consequences. But on a time scale that nobody worries about, because it's not our watch. It's our children and grandchildren. Let them worry about it. On the longer term, there's an even larger catastrophe in store, and that is the collapse of the West Antarctic ice sheet falling into the Antarctic Ocean, raising sea level by tens of meters all over the planet, and that means inundating every coastal city on Earth. And that's a much less certain prediction, the time scale. It's a little like what Lester was saying about economic forecasting. That it's going to happen is reasonably clear. When it's going to happen is less clear for something like 150 years from now. Now, maybe before then we will have figured out alternative energy sources. But because the time scale is so long for scavenging carbon dioxide out of the atmosphere, what we do is fundamentally irreversible now. So this raises an important question. What are our responsibilities to 2, 3, and 4 generations from now? Bearing in mind that it is extremely unlikely that there will be a technical fix to this problem then. Notice that carbon dioxide does not respect national boundaries, has never heard of national sovereignty, and therefore the burning of coal in the United States affects the climate in the Soviet Union and vice versa. Suppose that we were smart and started limiting the use of fossil fuels, made massive investments in alternative energy sources, solar power, and ultimately fusion power, thermonuclear reactions. What would the consequences be? Well, suppose the United States and the Soviet Union in 30 years, not out of the question, had economically viable fusion reactors and replaced their entire fossil fuel economies, despite enormous resistance from fossil fuel corporations, and would then everything be fine? Everything would not be fine. The third largest coal producer on the planet is China. China is in the throes of massive industrialization. Can we imagine the United States and the Soviet Union going to China and saying, look, we know we made some mistakes in our industrialization using fossil fuels, but please learn from our mistake. Don't you use coal as well, otherwise our farmers in the Ukraine and the Midwest are going to be in trouble. What's in it for China? I think the United States and the Soviet Union would have to provide the alternative power technology at a rate which was competitive with Chinese use of coal, which will be very cheap, in order to make much of a dent in Chinese thinking. Possibly China will be much more altruistic and planet-oriented than the United States and the Soviet Union, but I wonder if we can bet on that. Well, this is a kind of prototype of a generic set of problems that worldwide technology now brings before us. A set of problems which involve unanticipated negative consequences of apparently benign technology, consequences very severe, consequences that are global in nature, and therefore that cannot be solved even by one or two of the most powerful industrial nations by themselves. It requires the entire industrial world to deal with. Let me give another example. We talked about the visible part of the spectrum and the infrared, longward of red, while going the other way, shortward of violet. There's another part of the spectrum that the sun puts out, that every object puts out, but that our eyes are not sensitive to, called the ultraviolet. Ultraviolet light is very dangerous because the molecules that make us up, especially the nucleic acids and the proteins, fall to pieces or undergo chemical reactions when exposed to ultraviolet light. We ordinarily don't have to worry about that because we have an ozone layer. Ozone is 3 atoms of oxygen, chemically bound, that a kind providence has put up 25 kilometers to 40 kilometers in the sky, and it absorbs almost all of that ultraviolet radiation. There's very little ozone, however, up there. If it were brought down to this room, the thickness of the ozone layer would be 1/4 of a millimeter thick. It's small, and therefore it's vulnerable. Now, in refrigerants and decreasingly in aerosol propellants, and as a degradation product of some plastic, styrofoam, and the like, is a set of molecules called chlorofluorocarbons, CCFs. The brand name of the most widely known is a DuPont brand name, Freon. These molecules have been chosen precisely because of how chemically inert they are. No harm if you breathe them. They don't interact with anything around here. It sounds like the ideal kind of byproduct for some industrial applications. But precisely because they're so inert, they stay around for a long time. They get out into the open air. The atmosphere circulates them. And eventually, they wind up high in the atmosphere, where they bump into ozone molecules, and ozone is sufficiently reactive to combine with the CCFs and fall to pieces. Well, what is happening is that the ozone is declining. There is a unpredicted and extremely worrisome hole of large dimensions in the Antarctic ozonosphere. There are other holes in the ozone which are appearing now in Spitsbergen and elsewhere. And it seems very clear that the production of chlorofluorocarbons is in the process of compromising the global ozone layer. And the time scale for these molecules to be scavenged out of the atmosphere, in part by interaction with the ozone, is something like a century. So if we stopped right now all CCF production, 100 years from now, the consequences would be apparent. Now, what would happen if there was a significant decrease in the ozonosphere. A superficial consequence, which is what one mainly hears about, but it's by no means the most worrisome, is an increase of skin cancer in people with light skins. People with dark skins are better protected. This is one of the few cases where there's a kind of technological justice. The people who do the technology carelessly are the ones who are preferentially destroyed by it, and dark-skinned people who didn't do it are not bothered by it. In most cases, it goes the other way, that the people who had nothing to do with the technology are the ones who most suffer from the negative consequences. But much more important than skin cancer is the fact that there's a vast range of microorganisms that are exquisitely sensitive to increased ultraviolet light. For example, the phytoplankton at the surface of the oceans, which are the primary source of molecular oxygen in the Earth's atmosphere. There is a vast ecological pyramid. You know, these guys harvest sunlight, and then these guys eat those guys, and these guys eat those guys, and way up at the top, that's us. And we eat them, who eat them, who eat them, who eat them, who eat these guys who are sensitive to ultraviolet light. Now, this web of interactions is extremely poorly studied, extremely poorly understood, but I don't think it's being alarmist to say that there's something to worry about here. And to try to deal with this issue, large number of industrialized nations, United States and Canada, Western Europe, the Soviet Union, Japan, have been meeting and have agreed in principle on emission controls of chlorofluorocarbons. There are special cases. The Soviet Union and Japan want some exclusions for a period of time so as not to harm their domestic industry. Some U.S. corporations have been very responsible on this issue, even if it involves some loss of profit. But this is another example of an accidental byproduct of high technology that has global venue, that involves all industrialized nations, that has possibly extremely serious consequences. And there are others. Acid rain, for example, radioactivity from nuclear reactor accidents. One very worrisome aspect, though, is if you look how these dangers were uncovered, they were uncovered absolutely accidentally in the byproduct of some other kinds of scientific investigation, and very late, which suggests that there is probably a significant category of other serious global consequences of technology that we haven't been smart enough to figure out yet. Other discoveries along these lines will be made in the future. We could even describe some epidemic diseases like AIDS as in this category, because they clearly are significantly assisted by advances in transportation technology, so that the world is, to a significant extent, a sexually intercommunicating whole. And the exponentiation of a number of AIDS cases worldwide is now something very serious, because exponentials beat everything. And this may very well have powerful consequences in the distribution of power worldwide. For example, Soviet Union and China have disproportionately extremely small incidence of AIDS, because they are not as sexually intercommunicating with the rest of the world as many other countries. It is possible that one consequence of the AIDS epidemic is to leave the Soviet Union and China in a disproportionately better off situation than the industrialized West and Japan. That might be the single most significant determinant of the balance of power among nations on the planet, and not economics, not nuclear war, not anything else. And who would have figured that? Well, I want to say a few words about the nuclear arms race. It is, in a way, in this category as well. And one way to look at it is the following. In 1945, just after when Lester began with Bretton Woods, the United States was the most powerful nation on the planet, not just economically, but militarily. It was invulnerable. Surrounded east and west by impassable oceans, north and south by weak and friendly neighbors, the United States had absolutely nothing to worry about in a military sense, at least in terms of direct aggression by other nations. The United States then developed nuclear weapons, and their delivery systems, has been the leading nation on the planet in ever increasing the sophistication of these weapons and their delivery systems at enormous cost. I'll say something about cost in a moment. And driving, I think there's no doubt that it's American technology that has driven the nuclear arms race much more than Soviet technological advances. The Soviets are always in the situation of huffing and puffing to follow up and try to match or counter American advances. And the net result is that today, the United States is exquisitely vulnerable to utter annihilation because of the very technology that the United States pioneered in the development of nuclear weapons. We are alive in the United States today because Soviet leaders did not 20 minutes ago decide to annihilate us. And Soviet citizens are alive today because 20 minutes ago American leaders did not decide to annihilate them. Everybody in the United States is vulnerable in extremely short timescales, a fuse 20 minutes long, because of this technology designed to protect ourselves. There is a kind of irony. Now, the nuclear arms race is so invested with national propaganda on both sides that, of course, both sides have a list as long as your arm of the abuses by the other and all the reasons why it's essential to have nuclear weapons to protect ourselves. But the net result is that nobody is protected and everybody is vulnerable. There are some 60,000 nuclear weapons in the world. The planet has been booby-trapped by the United States and the Soviet Union. Of those 60,000 weapons, almost 25,000 are so-called strategic weapons, that is, connected to delivery systems that carry them from the homeland of one superpower to the homeland of the other superpower, and the remaining 30 to 35,000 nuclear weapons are so-called tactical nuclear weapons, some of which are given demeaning names like munitions, but most of which are more powerful than the bombs that destroyed Hiroshima and Nagasaki. How many cities are there on the planet Earth? There's about 2,300 cities, if you define a city as having more than 100,000 people. That means that the United States and the Soviet Union, if they wished to cooperate on this matter, by devoting 2 nuclear weapons to every city on the planet, could destroy every city on the planet and have 20,000 strategic weapons left over as a challenge to the targeteers to figure out what to use those weapons for. I think it's very clear that no matter what the function of nuclear weapons are, there are far too many of them. In a so-called central exchange between the United States and the Soviet Union, estimates of the prompt fatalities, that is, within a few days to a few weeks, range from many hundreds of millions to a high estimate by the World Health Organization of about 2 billion people killed, outright. And that's mainly from blast, fire, prompt radiation, and short-term radioactive fallout. There are a set of And let me just list a few of them. There's long-term radioactivity, which spreads most of it hemispheric-wide, northern hemisphere. There's a northern mid-latitude target zone where the greatest vulnerability is, but the radioactivity spreads north and south of that. And some of it, we now know, spreads into the southern hemisphere. There is a new and very incompletely understood consequence from the burning of modern cities, the production of toxic smogs. You know how in the burning of a modern skyscraper, people are said to be overcome by smoke? Smoke inhalation is what it's called. That's not what happens at all. What happens is that in the burning of modern synthetics and plastics, a witch's brew of poison gases is generated. Carbon monoxide, dioxins, furans. And you breathe them, and it's like gas warfare, and you are poisoned. Now, in the burning of a modern city, those gases, all heavy, so they stay near the ground, spread out from the city into the surrounding countryside. And some estimates of how much of that would occur are very serious. This is not something that the defense establishments have discovered, and it's not something that they're interested in calculating. It's all been done by civilian scientists. And then there are a set of extremely serious climatic consequences which go under the rubric of nuclear winter, which is essentially a blocking of sunlight for periods between weeks and perhaps years, lowering of temperatures, 10 to 20 degrees centigrade change in the average temperature of the planet are what the range of modern calculations for a nuclear war that involves about a third of the strategic arsenals. The average temperature difference between now and the last ice age is 10 degrees centigrade. So we're talking about very serious temperature changes. The most significant adverse consequence of nuclear winter is in agriculture. The destruction of crops. For example, Canadian wheat and barley production is brought to zero by a 3 degree centigrade temperature decline. And it is estimated that from this source alone, starvation for several billion people is likely. There are also a range of synergisms, that is, cases where the sum of the where the net adverse consequence is more than the sum of the individual adverse consequences. And let me give just one example of how that would work. The prompt effects of the nuclear war destroy doctors and hospitals who are preferentially in the target zones and in the cities. The destruction of civil and sanitary facilities promotes the development of disease. Birds are preferentially killed by lowering temperatures and the radiation. They are a significant source of control of insects, which are disease vectors. So the birds aren't there. The disease carriers proliferate. Medical facilities are unavailable. And radiation levels that aren't enough to kill you are enough to significantly lower your immunity to disease. And one of the consequences of the sub-lethal radiation in a nuclear war, even in places far from target zones, is something like a global case of AIDS. That is, I mean, you don't have to do anything special to get it, except be complacent about the nuclear arms race. But what happens is your ability to resist disease is compromised at precisely the time when diseases are rampaging. That's an example of synergisms. Well, it can be argued that these consequences are so severe that we, of course, would not permit this to happen. and that great safeguards are taken to prevent accidental nuclear war, inadvertent nuclear war. But I think we only have to go back 2 years to two spectacular technological catastrophes of the two superpowers to see how bankrupt this argument is. I'm talking about Challenger and Chernobyl. Here we have high technologies in which enormous amounts of national prestige have been invested by the United States and the Soviet Union, and which nevertheless spectacularly fail. There are many ironies here, one of which is a year before Chernobyl, an interview with the Soviet deputy minister of heavy industry or something was published in the Soviet English language magazine Soviet Life, in which this guy, by bad luck, picked on Chernobyl as an example of the safety of Soviet fission reactors and estimated, she said it had been carefully done, that the average time to catastrophic failure for the Chernobyl nuclear plant would be 100,000 years. That's how long you'd have to wait before there was a serious accident at Chernobyl. And he was pointing to this as an example of the safety of Soviet nuclear power facilities. 1 year later, kaboom! And likewise for the Challenger space shuttle disaster, in which 7 astronauts lost their lives. Both NASA and contractor spokespersons had said less than a year before the Challenger disaster that the average time to spectacular failure would be 10,000 years. Now, these aren't just any old technologies. These are technologies which are important for the public images of the United States and the Soviet Union, where there isn't anything like the secrecy involved that there is in the nuclear arms race, and therefore the opportunity for vigorous criticism is much larger than in a compartmentalized, secret environment such as involves nuclear weapons. For these and similar reasons, the claim that yes, we have an extremely dangerous technology, but don't worry, we have absolutely impassable safeguards, should be greeted with some significant skepticism, in my view. And then beyond that, there is the evident fact, evident in the century of Hitler and Stalin, that madmen can achieve the highest offices in modern industrial nations. And in fact, I think it is apparent, even from recent history of many nations, that the psychological screening for highest officials is not what it might be. And therefore, it must be only a matter of time. It's very clear, for example, that in 1944 and 45, if Hitler had nuclear weapons, and the Allies had nuclear weapons, and it was guaranteed to Hitler that if Hitler used nuclear weapons, that Germany would be destroyed. That nevertheless, Hitler would have used nuclear weapons. In fact, Hitler was as angry at the German people for not doing some superhuman effort to deflect the Allied invasion as he was at the Allies. He wanted the German people to be punished. And that kind of psychology in a national leader with nuclear weapons is something, I believe, to be worried about. So, the nuclear arms race is something supremely foolish that we have done, always for patriotic reasons, always thinking the short term and ignoring the long term. It is a kind of machine that goes by itself. Each side's escalation prompts the other side to escalate, and is capable, certainly, of obliterating the United States and the Soviet Union, and Western Europe, Eastern Europe, China, Japan, Canada. That's, of course, not the whole planet, but for those of us who live in those countries, and even for a few others, that would be a significant loss. Nuclear war would very likely destroy the global civilization and conceivably, although this is much less certain, could end the few million-year-old experiment, human experiment on the planet Earth. Stakes are never higher. Here is an example of a technology that endangers everybody on the planet. And yes, there are some stirrings. We will, if all goes well, next month have a 3% reduction in those 60,000 nuclear weapons on the planet. It's at least a step in the right direction. But at the same time, the United States and the Soviet Union will be building more nuclear weapons than those taken away in the INF Treaty. Both nations build something like 2 or 3 net new nuclear weapons every day. This is going to take some doing to undo the nuclear arms race. In my view, what is needed is to bring it down at least to a kind of minimum deterrence in which each side retains an invulnerable capability to annihilate the other, but not enough to destroy the global civilization. That seems to me minimal prudence. I think there's a significant chance, I don't know what it is, it's certainly not as high as 50%, of doing that, but it's certainly not going to be easy. Now I want to say something about cost of the nuclear arms race, and indeed of armaments in general. The world spends every year $1 trillion on armaments. The United States and the Soviet Union vie with each other for the privilege of selling the most arms to other, usually developing nations. And this money, I think an extraterrestrial observer might believe is not being used in the most efficient way for human betterment. We could ask another question. How much money has the United States spent on the Cold War since 1945? Now, I'm not for a moment arguing that there aren't real reasons to have significant and prudent national defense, but I think a case can be made that you could do that with significantly less money than has actually been spent. How much money has been spent? By the time the Reagan administration leaves office in January 1989, or conceivably earlier, the total amount in 1987 dollars that will have been spent on the Cold War is $10 trillion by the United States. What could you buy for $10 trillion? The answer is you could buy everything. Everything in the United States except the land you could purchase for $10 trillion. Highways, skyscrapers, ships, boats, airplanes, cars, schoolrooms, baby diapers, everything. So it seems to me that does raise the question of, has this been the most effective use of our money? And likewise, has it been the most effective use of the comparable Soviet expenditures? In addition to the question of the amount of money spent on this, there's the question of the deflection of scientific and engineering talent away from the civilian economy. More than half the scientists and technologists on the planet today are employed by the various military establishments. What would happen if a significant fraction of them were pried loose to develop other kinds of technology that might be a little more beneficial? As Lester mentioned, the United States has gone within the last few years from being the largest creditor to the largest debtor nation on the planet. The national debt is not only larger than that of any previous administration, it is larger than the sum of all previous administrations back to George Washington. Since 1980, the annual increase in the budget deficit is almost exactly the annual increase in military expenditures. I am very far from understanding anything about economics, but it occurs to me that these two facts may be connected. I also wonder if the boom in the German and Japanese economies might have something to do with the fact that their military budgets as a fraction of gross national product have been extremely low because of the United States supplying a significant amount of their defense and concerned by other nations that Japanese and German rearmament in the light of World War II may be undesirable. There is a sense in which, and this may be too strong, I'll say it anyway, in which the United States is showing signs of being a kind of developing nation. It is 17th in the world in infant mortality. A quarter of the population is functionally illiterate. High school students all over the United States cannot locate the United States on an unmarked world map, have no idea where their own country is. I saw one excursion of this sort where a student asked to identify where the Soviet Union was, pointed to Nicaragua. This may be a consequence of the success of the president's propaganda, but it is geographically incompetent. Patent applications are steeply down. There are evident homeless people in every major city. 20 million people in the United States are hungry every day. That is, skip one or more meal because they can't afford it. There are half as many graduate degrees in science and technology every year in the United States than in Japan, which has half the American population. Public transportation and urban infrastructure in general are a disgrace by, say, European standards. There are lax environmental standards. In some respects, the United States is one of the most backward nations on the planet in dealing with its technological waste. And the kind of decisions which are in effect made are that we need the jobs so desperately that we will sacrifice the health of some of the citizens. The United States is 14th in the world in percent of the population with safe water. Now, all of these things are connected with money. You could solve these problems in the United States if there were more money available to do it. Why is that money not available? It seems to me it is very clear that one of the chief reasons it's not available, both in the direct sense and in the indirect sense of what those scientists and technologists could do if they weren't working for the military, is the military budget. And any attempt to emerge from the global economic crisis, which Lester has outlined, seems to me, and I claim no significant expertise here, to have to deal with the question of the massive military budgets of the United States and the Soviet Union, and indeed in the developing world as well. This has clearly been recognized by Mr. Gorbachev, who makes it clear that one of the reasons he's interested in both nuclear and conventional arms reduction treaties is to free up some of the military sector of the Soviet economy for civilian uses. And to do that, there are changes needed in the openness in the society and the freedoms which are given to citizens. Very hard to do significant pioneering science and technology in a society in which you are not permitted to make public criticism. Criticism is the lifeblood of the scientific method. And so from economic necessity, freedom is, at least to a limited extent, is driven. And precisely the same thing is true in China, and the statement has been explicitly made by Deng Xiaoping. I guess what I'm saying is the definition of national security involves more than how many weapons you have. In fact, in terms of nuclear weapons, there is certainly a point in which the more nuclear weapons you have, the less safe you are, as I was trying to argue before. There's a kind of counterintuitive aspect of modern technology in the military and in the civilian spheres. And there is a necessity after 1945 of what Einstein called a new way of thinking, which is very slowly permeating into the minds of leaders. On the question of the definition of national defense, I'd like to read to you a one-sentence quote from Dwight Eisenhower. "The problem in defense spending is to figure how far you should go without destroying from within what you are trying to defend from without." And any definition of national security, it seems to me, has to involve the well-being of the citizens, economic well-being, a positive sense of the future based not on pap but on real expectations, education, especially in science and technology. The scientific illiteracy of Americans in general is scandalous. Every day there are significant decisions made in Washington involving science and technology which have very long outreach into the future. And 435 members of Congress, there are perhaps 2 who in any sense have a scientific or technological background. The Office of the President's Science Advisor has been downgraded in recent years. The President's Scientific Advisory Committee was canceled in the Nixon administration because it gave advice that was politically undesired. The laws of physics did not correspond adequately enough to the ideological wishes of the leadership. And no subsequent president has thought it advisable to resuscitate the President's Science Advisory Committee. For a nation which is in many significant respects dependent upon science and technology, to arrange things that nobody knows anything about science and technology is clearly suicidal. And some of the problems that I've been mentioning before are connected to this. How is it we didn't foresee the consequences of many of these technologies? It's because there's a very small science and technology base in the United States. There's a small science and technology base in the Soviet Union as well, but they're doing a lot more in scientific and technological education than we are. How much science and technology do you see, for example, in the mass media? Every newspaper in America has a daily astrology column. How many have even a weekly science column? Why is this? How much science do you see on television? When somebody wins the Nobel Prize, do you ever get a coherent explanation of what he won it for? What was this discovery that was important enough to win a Nobel Prize? Well, the basic sense in television is that the American people are too stupid to understand, and that it takes concentration, and therefore in the quest for small differential advantage in the competition between the networks, that it will be a means of losing ratings to spend time explaining what science is about. Short-term advantage for the network, long-term disaster for the country. Well, I have just one concluding remark, and that is that I know I've been slightly negative in this presentation. There is not the slightest doubt that science and technology, but in particular the scientific way of thinking, can be used in a very significant way to turn around many of these problems and to work for human betterment. But it requires a break with the idea that everything we've done in the past is okay and any criticism of it is impermissible. That so many people, for example, of both political parties, and in fact in the United States and the Soviet Union, have invested their entire careers on the advisability of the nuclear arms race, that already means that there is a vast vested interest in turning things around. And this is true in many of the other technological areas that I mentioned. In order to justify a lifetime of somnambulance on the critical issues, people are reluctant to even have those critical issues addressed. So what I think is most urgently needed in all aspects of life in the United States and the Soviet Union and elsewhere is a comprehensive baloney detection kit in which the average citizen can treat with appropriate skepticism remarks made by high government officials and those justifying the continuance of the way we've always done things, whatever those things are. I think widespread critical thinking is an essential precondition for the higher standards of leadership that we desperately need, and for the higher standards of education and awareness of the problems we face, which I think is required of every citizen. Thank you.
Thank you very much, Les and Carl.